Hey, super scientists, we're looking at 2.3, water on Earth, and we're going to be talking about water resources. So water covers 75% of Earth's surface. That means 25% of our surface is land. That 75% of our surface is used for a lot of things. Water is very important to us, and water in general, ocean water or fresh water, both are very important to habitats, to individual organisms. So why do we need water? So all living things are going to need water for processes that take place within your body and within your cells. That includes living things like humans, animals, plants. Plants are going to rely on water for photosynthesis. We use water, fresh water, to drink. Animals depend on plants in order to have food for herbivores. And water is going to be a habitat for a lot of different animals. And that could be ocean habitats or it could be freshwater aquatic habitats. So 97% of Earth's water is salt water, and that means it's going to be water that contains some amount of salt, and it's primarily going to be found in the oceans. Of all of the water that we have on Earth, most of the water is going to be salt water, that 97%. That means that it only leaves 3% left that is going to be fresh water. And most of that fresh water is going to be stored in ice or glaciers. It's going to be frozen. So if you look at this distribution here, this pie chart, it shows us our 97% of water that is salt water. This small little piece of the pie here is our fresh water. And that is broken down into primarily ice. 76% of it is ice. And then our next largest chunk is going to be groundwater. So if we're including the shallow and the deeper groundwater, that's going to be 23%. And then a small amount is in lakes and rivers, and a small amount is found in the atmosphere as water vapor. The hydrologic cycle, the water cycle, we've talked a bit about this in the past. So the water cycle is just going to be the process where water moves on our surface, underground, up in the atmosphere, back and forth. So the different parts of the water cycle, there are three main parts that we usually think about with a water cycle: evaporation, condensation, and precipitation. So evaporation is going to be where those molecules get hot enough that they move so fast they turn from liquid to a gas, and that gas is then called water vapor. There's a specific type of evaporation that happens from plants, and this is called transpiration. So transpiration is just evaporation from plants. It's going to be where water will exit through the leaves of a plant through the stomata, those little openings on the underside of a leaf. Condensation is going to be where you have water vapor, water that is a gas, where it cools down and it turns back into liquid droplets. And if this happens around condensation nuclei, if it happens around dust particles, then it's going to form clouds. And our third step is precipitation. So this is our third main step that we think of. And precipitation is just water falling from the clouds and is primarily going to be in the form of rain, sleet, snow, or hail. Runoff is another part of the water cycle that's important. So this is going to be water that is not absorbed down into the ground. It's going to be water that is standing water. It's water that's moving across our surface. And generally that's because you've had so much rain that the ground can't absorb any more water at that moment. So eventually that water will move downhill and into a storm drain or into a river or a lake. Infiltration is just the process of the water moving into the ground. And once the water has moved into the ground, once it's infiltrated down through the ground, it will become part of the groundwater. And the groundwater is just water stored under the ground. And it's stored in a special place that's called the aquifer, which we'll talk a little bit more about later. So another type of fresh water on our surface is lakes. So we're all familiar with lakes, but lakes can change over time. And one of those processes is called eutrophication. Now, this does not happen to every lake, but this happens to lakes where you have a large amount of nutrients, like nitrates, that build up in the lake. And this causes additional algae to grow. This can lead to the death of a lake or a pond. And what that means is it can lead to the lake being filled in with a lot of different plant material. So if you look at this picture, we start off with a nice lake, a little bit of sediment at the bottom. Over time, as nutrients have been added to the water for whatever reason, and these nutrients could come from waste or fertilizer, maybe there's a a farm nearby that has a lot of fertilizer that runs off into this water source. So you can see that there's a lot of vegetation that is continuing to kind of creep in on the riverbanks there, and a lot more sediment at the bottom. And then finally, we have more vegetation. We have more plant life than we have water, and it's become really thick sediment at the bottom. So we started out with a lake, and eutrophication has been occurring, and now it's completely filled in, and there's not really any water there. A few puddles, maybe. Nitrates are one thing that is important to plants in being able to help plants to produce proteins. So nitrates are just going to be nitrogen. Usually they're nitrogen and oxygen, phosphorus compounds that help plants to grow. Nitrates naturally are going to come from waste. And when I say waste, that means poop. And also from fertilizer. So if you have a farm that's near a lake, that farm may be using some type of fertilizer on its plants to help the plants grow bigger, better, and stronger. So if that fertilizer gets into the water, a lake that's nearby, is going to cause more algae to grow, which can eventually lead to eutrophication occurring. Wetlands are another type of freshwater source. Wetlands, like the Everglades in Florida, are going to be areas of land that are covered in large part by water, and this could be seasonally or it could be all throughout the year. There are a couple different types of wetlands: swamps, marshes, and bogs, and we see marshes a lot near the beach. There are a lot of benefits to wetlands, and there's a lot of reasons that wetlands are important. So wetlands are going to form where water is trapped. They're going to help control floods, and so as you have a lot of rain, wetlands, since they are land areas that are primarily covered by water, they can absorb additional water, and it doesn't really affect that particular ecosystem. Wetlands are also going to provide a habitat for many animals. Wetlands are also going to be natural filters. So the vegetation that is in the wetlands will be able to absorb and break down some of those pollutants that may be trapped in the water. Wetlands are fragile environments, so they can be affected by chemicals from farming or chemicals from other sources. Developers sometimes fill in wetlands to use for construction of homes and malls and things like that. And new organisms may compete for space and food. So if you're reducing their habitat, then there may be additional organisms that are trying to live in those places. And levees and canals may cause flooding or drying up. So you're going to have wetlands a lot of times near the coast, but also in some other low-lying areas. And if you have threats to flooding of the area, sometimes you have levees or canals that are built to help prevent flooding of homes and communities. So that could cause a wetland to dry up. So again, wetlands are important because they're habitats for animals. They provide food, they provide shelter. They're also natural filters, and they help to absorb extra runoff, which means they're helping to control floods. So an aquifer, we talked about this a few minutes ago. Groundwater is going to be water that's stored underground, and the groundwater is going to be stored in the aquifer. Your stem aqua means water. So the aquifer is just going to be the underground rock layer that contains the water. So if you were to drill a well down into the ground, if you drill a well deep enough, then you may hit the water table, which is the top of this water area here. So if you've drilled that well down into the aquifer, then you may be able to get water from that well. So water that infiltrates down into the ground is going to move between rock particles of soil in these little cracks, these openings, and rock layers. So in this image, you can see a couple of different things labeled. So this is the unsaturated zone. So that means that it does not have a lot of water there. And the saturated zone is going to be where your aquifer is. That's going to be where it contains water. Now, there are a couple drips of water in the unsaturated zone, right? So this water is infiltrating, it's moving down, and it's going to kind of pile up here where you hit this solid rock, this impermeable rock, which is usually like granite. So water that's stored in an aquifer is going to be cleaner than other sources, and that's because the impurities are going to be trapped in the overlying rock layers and sediment. So as the water is infiltrating down through the ground, those chemicals and pollutants are going to get trapped among all these particles, and that means the water is going to be pretty clean down here in the aquifer. So permeable materials are going to allow water to pass through them. Your topsoil and sandy layers here, those are going to have large sediments. They're going to have connected pores, which means the water is going to be able to move down through this layer. And sand and gravel are some other examples. And impermeable materials. So impermeable materials are not going to allow water to pass through them. They aren't going to have a lot of openings in them. So an impermeable material in this picture is going to be granite. Clay is another example. So you can see that there are some little pores in this particular granite, but they're not connected together. Whereas in this one, on the left here in the impermeable layer, there's lots of little openings, so the water can be contained within that. So looking at this aquifer, what's the mechanism responsible for getting more water into the aquifer, for recharge occurring? If you look at this little animation here, well, what's taking place? It's raining. So as it rains, that water will then infiltrate down into the ground, and that is responsible for this aquifer recharge. So the way that you get more water in the aquifer is going to be rain.